Everybody, welcome Leonard Tramiel today. He is a board member of the Center for Inquiry, an advisor to SETI, the Search for Extraterrestrial Intelligence, which is what he's here to talk about today. You might know him from Atari and some other things. But this talk today came about because we were sitting around and trying to figure out what we wanted to do for a meeting this month. And Benny sort of out of nowhere said, you know, what's with this SETI thing? I don't know. I'm not so sure about it. What good's it really doing? And which is something you don't ordinarily hear from skeptics. Maybe you should. I don't know. And kind of later on, unrelated, somebody else said, can we get Leonard in to do a talk? He knows just about everything. And that was not even thinking about SETI. So I Googled your name, Leonard, just to again, see your resume, and SETI was the first thing that came up. So it was a very serendipitous moment. Must be one of those synchronicities.
It was meant to be.
Craig was the one who was looking for Leonard. Say hi.
Well, hey Leonard, after meeting you year after year at Nexus, for the 2 or 3 seconds I had to say hello, anything I've asked you or you've talked about has always, set the record pretty straight, and never any real bias, just enjoyable, always enjoyable to listen to you.
So I should quit while I'm ahead?
Yeah, you should just hang up now before you get in any trouble.
Thanks.
Well, like you said earlier, Leonard, at least we're acknowledging your bias as an advisor to SETI. So we'll see if you can work in that capacity and advise us into believing it's worth anything. So whenever you're ready, go ahead, please.
All righty. So I'm going to see once again if I can share my screen.
Did you set that up?
Yeah, we tested.
Perfect. Excellent.
All righty. So I assume everyone can see this brilliantly constructed piece of art, some black letters on a white background. Everybody see that?
Yep.
All right. So I realize that the title of this talk is a bit confrontational. To be very clear, I'm going to be very explicit in a few things that I might be able to take for granted. First, what do I mean by skepticism? I'm using the term to refer to the position taken by Martin Gardner, Ray Hyman, and James Randi when they formed SIR, Sanity in Research, later formalized by CSICOP, the Committee for the Scientific Investigation of Claims of the Paranormal. These are that people are prone to reach conclusions that aren't supportable by the available facts. We often reach conclusions because we like them, even if the facts don't support them. We are led astray by cognitive biases and illusions and other flaws that are built into the ways that we think. Skepticism tells us that the use of science and reason is vital to overcome these tendencies. This was simplified and popularized by Carl Sagan in the well-known phrase, "Extraordinary claims require extraordinary evidence." That has been shrunk down to its core in the phrase, "I doubt it," for what is now called CSI. I think it's useful for any group to check how well it's doing in reaching its goals. I see one of the goals of modern or scientific skepticism is the evaluation of as close to as all claims as possible to see if they're supported by the evidence. We've been doing this in a wide variety of areas, and a few of them have been quite successful recently. The recent interest and publicity over UFOs, or UAPs as they've been known these days, has seen the skeptical view presented quite prominently. For example, your most recent speaker, Mick West, who I have the misfortune of following. I hope you don't judge me by the standard he set. We can also include the domain of alternative medicine, where the current pandemic has focused much needed attention on the fact that bogus medical advice exists and showing some of the techniques that can determine if a treatment should be trusted. If more people had embraced the skeptic's view of reality, I think the death toll of the last year and a half would have been much lower. One of the things I've come to realize after being involved with skepticism for quite a while now is that all of us are susceptible to these flaws. Even in skeptics meetings, I have encountered people that seem to think that this doesn't happen to them. They're wrong. By being aware of the problems built into our cognition, we can reduce the mistakes we make, or more likely, correct them quickly, but only sometimes. All of us fail in some areas and accept ideas that are not supported by the available evidence. If this were a live talk, I could ask you to raise your hands. I guess I could actually do that virtually as well, but not sure how many of you are going to be able to do that. And see if you think that the following assertions are well supported by empirical evidence. So are you guys still seeing my slide?
Yes.
Good. So first, viruses are a source of human disease. 2, homeopathic principles lead to effective medical treatments. 3, quantum mechanics allows cats to be dead and alive at the same time. Oops, left out a word. And 4 is a little longer. The chemical elements that form the building blocks of life are ubiquitous in the universe. More complex molecules like amino acids are commonly found as well. With 1 trillion planets in our galaxy, it is certain that life is present on other planets. I'm pretty sure that the majority of you said that 3 of these assertions were scientifically sound, or would if you hadn't seen the title of this talk. You'll probably be surprised that only the first one is true. I'm confident all of you knew the second is false, and the third's a topic I'm doing some writing on at the moment. The last one, however, is a pretty common belief. In fact, the conclusion that life was common in our galaxy was quite popular even before we knew that there were a trillion planets there. Not only is it common in our culture in general, it is also common among skeptics. I've seen a lot of people at skeptical conferences, remember those? And the majority would express the belief that life was common. It's also common among prominent figures in skepticism. For example, Brian Dunning has said, quote, "It's practically a mathematical and statistical certainty that life exists elsewhere." Of course, he would have said it in a much deeper and richer voice. Bob Novella frequently says similar things. The first part about the components of life being common is true. We know from spectroscopic observations that the elemental composition of other stars, and by reasonable extrapolation, other planetary systems, is much like our own. Even more telling, we have observations of amino acids in many dust clouds in our galaxy. This eliminates many of the arguments that could be made to show that life on Earth is unique or at least unusual. But it is important to realize that that doesn't support the assertion that life is a mathematical and statistical certainty. A very useful framework to look at these questions was developed by Frank Drake, the Drake equation. The first factor, the rate of star formation, is well known and not relevant to this discussion. The next 2, the fraction of stars with planets and the number of planets that could support life per star, are far better known now thanks to recent advancements, primarily the Kepler Space Telescope and the HARP spectrograph. This is the reason we can confidently say there are a trillion planets in our galaxy. So this is a pretty busy image. It's not sure how well this can be read. This is a chart of all of the currently confirmed exoplanets that are known. Along the x-axis, we have a logarithmic display of the period in days, and the vertical is another logarithmic graph of the mass in Jupiter masses. And the color codes show the different techniques used to find the planets. The Kepler Space Telescope has gotten a lot of coverage, and I suspect all of you are familiar with it and the transit method it relies on. If not, we can talk about that in the Q&A. This is not true of HARPS. The acronym stands for High Accuracy Radial Velocity Planet Searcher. It is located at the La Silla Observatory, operated by ESO, the European Southern Observatory, in the Atacama Desert in Chile, and mounted on a 3.6 meter telescope. It detects planets, as indicated by the acronym, by using the radial velocity of a star as it moves around the center of mass of the star-planet system. This method is responsible for the second largest number of confirmed planets, as shown in this figure. The transit method points are in green. The radial velocity ones are in red. It's interesting to note that this method is far more sensitive to planets with longer periods, so it finds planets that the transit method isn't all that sensitive to. This is how the first planets around regular stars were found. The first such exoplanet to be discovered imparted a velocity of 53 meters per second, or about 120 miles an hour, to its star, 51 Pegasi. HARPS can detect radial velocities of less than 1 meter per second, far more sensitive. This would allow it to see the radial velocity imparted on our sun by Jupiter, Saturn, and Uranus. A couple of the more significant results from HARPS include finding that about 40% of red dwarfs have planets in the habitable zone for those stars, and a planet around the closest star to our sun. As an interesting aside, I'll note that there's a new instrument, ESPRESSO, for a shell spectrograph for rocky exoplanets and stable spectroscopic observations. I wonder how long it took to come up with that. ESPRESSO increases sensitivity to around 50 centimeters or less. This will allow us to find even more planets and characterize the types of solar systems in our galaxies. The next factor in the Drake equation, F sub L, is the last one relevant at this point. The fraction of planets that could support life that actually develop life. It's basically the fraction of planets upon which abiogenesis occurs. Abiogenesis, the natural process by which life has arisen from non-living matter, is an active research area. Although there are many proposals made to describe the process or components of it, we still don't have a detailed knowledge of how it happened on Earth, or even how it might have happened. The fact that life began on Earth in a geologically short time is often cited as evidence for indicating or estimating that F sub L is near 1. If we use the Copernican principle, otherwise known as the principle of mediocrity, we are led to the idea that F sub L is basically 1. If it happened here, it could happen other places. However, estimates based on the probability of self-replicating amino acid chains randomly forming gives results near 0. Our ignorance of the value of F sub L is essentially complete. We just don't know. And I think there is really only one appropriate reaction. No matter what other factors that go into our estimates, if the best we have for one of them is I don't know, then the product is I don't know. I don't know times any number is I don't know. And I'd like to thank my friend Jay Diamond for introducing me to the mathematics of I don't know in a talk of a similar nature. I don't see any other conclusion that could be supported by what we do know. Saying either F sub L is low or high isn't well supported by actual knowledge. I see asserting any conclusion about F sub L as a failure of skepticism. If life happened quickly on Earth, and there are many planets out there, it seems quite reasonable to think that it exists on some of those planets. This is good evidence that life doesn't need to be rare, but to conclude that life is common ignores what I think is the only scientifically reasonable answer. We don't know. To put this in the context of Sagan's maxim, I think that part of the reason this failure occurs is that the claim of extraterrestrial life just doesn't seem like an extraordinary one. We have good reason not to reject that life may be common. And when we combine this with the familiarity all of us have to living beings, we're lulled into a conclusion. We are swayed more by the availability heuristic than solid reasoning. So what does this say about SETI, the search for extraterrestrial intelligence? The rest of the factors in the Drake equation don't matter at this point. I don't know was still the answer. In the interest of full disclosure, I'm a big fan of SETI, and I serve on one of the SETI Institute's advisory boards. This might make you wonder why I would work with the SETI Institute, given the highly speculative impression I have of SETI. Well, there are a couple of reasons for this. First, I'm not opposed to highly speculative efforts. The question, are we alone, is an old one that has captured the attention of both experts and lay people for millennia. If SETI succeeds, just imagine what we could learn. At this point, one of the most profound questions they might be able to answer is, how did you not destroy yourselves? We might also be able to learn new scientific ideas, possibly in areas we don't even know we're missing. We could also learn what it means to exist from another, probably very different point of view. On the other hand, if after an extensive search, far more than we have done to date, SETI doesn't succeed, we will know that we are very rare, if not unique. We will confirm that we are precious. As Jill Tarter said in her TED Talk, we live on a fragile island of life. If that island isn't one of many, we need to protect it. First, let's see what some SETI folk say about it. Seth Shostak, senior astronomer at the SETI Institute, has often repeated that he will bet that we'll find intelligent life within 20 years. I think he started saying that about 3 years ago, so we've got 17. That sounds like a pretty bold statement until you see that the bet is for a cup of coffee. One of the most well-known people involved with SETI, I mentioned before, is Jill Tarter. In her TED Talk, she said that, when she was given the TED Prize, she said, SETI doesn't presume the existence of extraterrestrial intelligence. It merely notes the possibility, if not the probability, in the vast universe, which seems fairly uniform. On several other occasions, she said, if intelligent life isn't common in our galaxy, given the large number of planets, it's a terrible waste of space. Echoing the words of Ellie Arroway, the protagonist of Carl Sagan's novel Cosmos, who is widely regarded as being at least partly based on Jill Tarter. It strengthens the plea of Carl Sagan. This image of our tiny world underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. I hope all of you recognize that image as the pale blue dot. Let's see if we can point it out. You might be able to see my cursor. It's right there. I think I skipped ahead accidentally. But there's more to it than that. As SETI searches utilize new technologies, the knowledge gained adds to humanity's store and helps all of science. For example, with current technology, we can produce very narrow bandwidth signals, very short ones as well, that exceed the brightness of the sun during that pulse. We can also detect these with a fairly new field called optical SETI. When we have built new ways to view the universe, we find things that weren't expected. Who knows what will be discovered as the result of these new detectors? The Institute is currently developing and deploying a set of detectors called laser SETI that are looking for the brightest and longest of these signals. Will it find a new class of astronomical objects? I look forward to finding out. Because SETI, and in particular the SETI Institute, is a science-based organization, the questions they investigate haven't been limited to, are we alone? The mission of the Institute is to explore, understand, explain the origin and nature of life. This is very close to the usual definition of astrobiology, which is usually defined as the study of the origin, evolution, distribution, and future of life in the universe. The majority of scientists and activities in the SETI Institute are basically astrobiologists, part of the Carl Sagan Center for Research. Their activities span a huge range. Some of it has an obvious SETI connection. For example, much of the data analysis for the Kepler and TESS spacecraft planet finding missions was and continues to be done by SETI scientists. SETI scientists also work on the Gemini planet imager. There's also work being done on a wide range of solar system planetary science. SETI scientists were involved in the site selection for the most recent NASA Mars rover missions and have been producing papers on a wide range of topics about Mars and other planets. There's also work being done on smaller bodies in the solar system. I don't know how many of you have seen this. There's a recent announcement about the 3D modeling of the asteroid Cleopatra, images of which are on the screen now. The lead author is a SETI scientist. This analysis is a really deep rabbit hole that I had a bit of trouble climbing out of in time to finish this talk. Not only does the asteroid look like a dog bone, it also has a couple of moons, and combining all of the available data, some of it obtained by the now destroyed Arecibo telescope, was, let's just say, complex. Another area is work done by CAMS, the Camera for All Sky Meteor Surveillance. Here's a picture of a couple of CAMS apparati and the person who's largely responsible for it. This system uses a multiple set of video cameras to determine the orbits of meteors. The work is based on previous data taken with a set of 35mm cameras. I'm particularly interested in this since I help operate one of those 35mm camera systems. That involves staying up all night during a meteor shower, cranking the film advance and pressing the shutters on several cameras at regular intervals, a particularly frustrating thing for me to do because it meant, as an amateur astronomer, I couldn't stargaze or meteor count. The sky conditions were great that night and it felt wrong not to take advantage. This has led to new information about meteor showers and the bodies that cause them. The parent bodies of some showers have been identified with this work. This is putting real world constraints on solar system formation. The same team has collected samples of meteorite falls from around the world. Asteroid 2008 TC was the first case where a known object was observed in space and then samples were retrieved by this group. By going to those locations, it's possible to use on-site data and photographs taken by residents to determine the orbit for objects for ones like the Chelyabinsk impact, where the object wasn't previously known. Another class of small solar system bodies that most people don't think of that way are planetary rings and moons. The Ring Moon Systems node of NASA's planetary data system is managed at the SETI Institute. This group worked to ensure the flight path safety for the New Horizons spacecraft and also the discovery of several moons in the solar system and ring systems on other planets. My background's in physics, so that's the subject that most immediately comes to mind for me, but astrobiology, as the name suggests, has a large biology component. SETI scientists do field studies all around the world in extreme environments like high mountain lakes, geysers, mud pots, the isolated sub-ice lakes in Antarctica, to collect and study ways that life has evolved to adapt to these conditions. Like this lake at an elevation of 5870 meters or 19,260 feet. They're also involved in crewed manned space efforts in projects like the Houghton Mars Project, part of a facility located on the world's largest uninhabited island, Devon Island. This harsh climate mimics the environmental conditions on Mars and other planets. Devon Island's barren terrain, freezing temperatures, isolation, and remoteness offer scientists and personnel unique research opportunities. Arctic day and night cycles and restricted communication capabilities offer fitting analogs for the challenges of long-duration space flights. The scientists also work in got a funny message. Sorry for the distraction. Also work in areas of animal language. This has, of course, a SETI connection, since it provides a path for learning about some of the ways non-humans can communicate. The Institute also has a large outreach effort, which is where most of my direct involvement has been. They've produced science curriculum materials, have the education and public outreach contracts for several NASA missions, work with many outside groups to increase understanding and appreciation of science, and have a lecture and talk series that goes back many years and continues to this day. This has barely scratched the surface of work being done at the Institute, but I want to end with going back to the search itself. This is the Allen Telescope Array up in Northern California, an interferometer now used exclusively by the SETI Institute for its work. As I've hopefully made clear, the search has stimulated a lot of really solid science in a wide variety of areas, but it also provides a vision that ties it all together. The search is an attempt to answer a profound question. No matter what the answer turns out to be, it's well worth knowing. We will either have discovered a source of information that may be superior to everything we have ever had, or we will have even more evidence of how precious our pale blue dot really is. It reminds me of a comment made to a US Senate committee about what became the Fermi National Accelerator Laboratory by its first director, Robert R. Wilson. Quote, "It has nothing to do directly with defending our country, except to make it worth defending," end quote. SETI is that kind of activity. It inspires. It forces us to think about our universe and our possibly very fragile place in it. It brings out in the scientific direction the best in what it means to be human. When I was asked to make the case that SETI was worthwhile, the first thing I thought of was truth matters, and profound truths matter even more. Thank you.
All right. Thank you, Leonard. That was great. Much appreciated.
And we've got lots of time for questions, which is
Yes.
always my favorite
That's good
part of the
because
talk.
that's good because I know I personally have a ton of questions.
Darn. All right.
Let's if anybody else has questions, we'll probably get to those first. Type question in all caps in the chat and followed by your question, and we'll see if we can get it asked to Leonard. Benny, I want to hear from you first. Are you convinced?
Well, it's not about being convinced, but one of the things that I get that, I mean, that was a very good argument that makes me think, and I like that. Is it worth, we're doing this to discover whether it's worth defending or to make clear that it is worth. But all of the projects involved in this don't cover the idea of intelligence out there. And most of the actual SETI research seems to be focused on discovering intelligence, right? And my question is, even in the Drake's equation, there's no mention of how hard, even if there is life out there, how hard it would be for it to be actually intelligent. And do you have any comments on that part? I mean,
Yeah.
finding life out there is, but can we really discover intelligence? The whole idea, if these planets are radiating some sort of intelligence, they would have to point it towards us for us to get it, wouldn't they? Otherwise, it would diffuse. I mean, these are all the issues.
No, that's not a couple of errors there. One is, of course, SETI, the acronym, the last letter in it is intelligence. It is a search for intelligence. As Jill Tarter has pointed out many times, the proxy they use for intelligence is technology. It's communications abilities. So by definition, SETI things look for intelligence, which is different than astrobiology, which is looking for life. The idea that they would have to deliberately point things at us is not correct. For example, right now, the most powerful radio signals that are being emanated from Earth are military radar. Those things scan the sky as the radar dishes rotate. Those would be visible as flashes in the radio from very far away because they're quite powerful transmitters. So we could find leakage, not deliberate communications necessarily, but leakage signals. So it's a little bit more complicated than you were indicating, and more likely to succeed as a result. But it's more than just finding out whether or not we're worth protecting. We're obviously biased. Many of us probably think that humanity is worth protecting, although there's less and less evidence for that every day, or at least more evidence to the contrary. But the possible gains are kind of huge as well. Did that answer more of your question, Benny?
You muted, Benny.
You're still muted, Benny. I can see your lips moving, but the red mute is still, there we go.
Now, yes.
Yeah.
No,
That answer-
now, yes. But also, no, I understand, but so it's sort of the Pascal wager idea, right? A lot of it is.
Well, it's a little bit more than Pascal's wager because we're not
Somebody
counting
wanted to
on.
somebody wanted to find that for.
Oh. You want?
You wanted to find that, or should I?
Well, but it's the whole idea that, yeah, we don't believe in God, but if it does exist, it's worth doing some stuff, because if it does exist, the payoff is so big that we
Right.
may as well do it with a small investment. The payoff could be huge, so it's worth it.
Right. And part of the reason that this is very different is the payoff doesn't require that we die first.
Right.
The payoff is now, or possibly in the future, but it will be for people that are alive. And right now, we get the payoff of lots of interesting technology and lots of interesting scientific advancement. If there's one thing that's really obvious from my background, it's that I'm really pro technology.
So just to finish, I'll let somebody else, but when you say the technologies we're developing, I mean, I fully understand the whole idea of finding exoplanets and finding planets and all that stuff. But when I think of SETI, and I could be wrong, I think mostly of antenna and listening into space and that kind of technology, which I believe is misrepresented in the movie Contact.
Yes,
Right.
it is.
Yeah.
Well, for example, the image that I showed last, the Allen Telescope Array, lots of really interesting cutting edge work was done to develop the interferometer that is used in that. And it's not just the antennas, but the data analysis and the ability to extract, I think it's 1 billion channels of information from the data stream, required lots of innovation that is helpful in data analysis of all sorts. So it's a pretty rich technological set of innovations.
It's kind of like a lot of people, when they say, why is space exploration in general valuable, and you can think of, well, people typically rattle off all the things we've gotten from NASA and the space program.
Right, which does not include either Tang or Teflon or Velcro.
Oh, oh, my words. I was just going to say that. Thank you.
Well,
Yeah.
well, then I don't care anymore. Forget it.
Or the Fisher Space Pen. There are lots of such spin-offs, but most of the spin-offs that people think of are not actually
Right.
spin-offs.
We get a,
The Tempur-Pedic mattress is a real one, though.
oh,
For those of you that like Tempur-Pedic mattresses.
Wow, that's great.
well, I'm sure a lot of people's backs will thank all the astronauts out there.
So I'm not going to go through the
Yeah,
the chat
I'll look
unless
at the
you want me
question.
to.
No, that's
But,
fine. I got a handle on it because I think we got
Please.
to punch here
There's a lot of them.
from Neerav first. I think I know the answer. I think I know what you're going to say, but let's see. When you say that life existing elsewhere is not a certainty, do you mean all forms of life or just intelligence? Similarly, just for this galaxy or for the whole universe?
Okay, so let's go backwards through that.
Yeah.
No reason to think that our galaxy is different than other galaxies. So whatever we say about our galaxy seems like it's going to be true for other galaxies. And I'm not saying that life isn't common. I'm saying we don't know. We just don't know. It might be, it might not be. Let's find out. I hope that answers the question.
Yeah. Rob's going to take it a step further here, though, and ask what you think about the rare Earth hypothesis. I know there was a book about it a while ago, a long time ago.
Yeah, written by a couple of religious apologists.
Oof, well, that hurts.
Not trying to poison the well
Sure.
or use an ad hominem or anything, because I would, as a
It's-
skeptic, I would never, ever do that.
It's important to have all the information.
Yeah.
So I'm going to guess your answer to that would be the same as in, I don't know. How can you know?
So what about, let me see if I can look at Rob's question.
Yeah, Rob's put a big mass text in here.
Want me to read it? Want me to basically say what it is?
Yeah, can you
No,
just
yeah, please do.
Yeah, so
Still Rob.
it goes much further than the I just don't know if abiogenesis is common. It says it tries to point out the huge odds against getting above that initial starting point, even if that were common to happen from what we perceived as happened on Earth, right? So the summary in one paragraph is in planetary astronomy and astrobiology, this hypothesis argues that the origin of life and the evolution of biological complexity, I would say more that, such as sexually reproducing multicellular organisms on Earth and subsequently human intelligence, required an improbable combination of astrophysical and geological events and circumstances, and therefore is not common, but likely to be very rare.
I think that's a garbled mess. The abiogenesis and the origin of life is a completely different question than multicellular life and sexual reproduction. So let's separate those two things first. The complexity of sexual reproduction, multicellular life, and then intelligence is obviously a much more complicated, difficult thing. And if we look in particular at intelligence, if we could ever decide what intelligence actually is, then it looks like it developed exactly once in 4.5 billion years and millions of or billions of species. So is it rare? It was certainly rare on Earth. On the other hand, we've got 1 trillion planets. Now that's a very different question than life itself. And that seems to have happened in a geological blink of an eye. What's so special about Earth? Why would it have happened here and not there? I don't know. We don't know how life starts. We don't know, well, heck, we don't know what life is. Defining it in the first place is hard. There's lots of work being done to try and answer that question. It's certainly an interesting one. Let's look. I think that the rare earth hypothesis is just as flawed from the hypotheses are great. The rare earth conclusion and saying that this hypothesis is anything new is frankly silly. People have brought up these objections many, many times in many, many contexts. and the book is really much more of an argument for the hypothesis than bringing it up. And I think having a conclusion, whether it's there everywhere or where it is, just unwarranted.
Yeah, it's hard to tell anything with a sample size of one.
Well, I mean, I wish that the worst part of our ignorance was the small sample size. Not only do we have precisely one example, we also don't know how the heck it happened.
Right.
I mean, if we find a unique unique ancient artifact, say the Antikythera mechanism, we know it exists. It's just one. Well, we don't know where it came from. The fact that we only have one of them isn't the biggest problem with it. The biggest problem with it is we don't know where it came from or why or what it was for. Yeah, it's yeah, n equals 1 is bad. Not having a clue is worse. And I think that's where we are. We don't have a clue.
Yeah.
And that's awfully hard for a lot of people, including scientists, to acknowledge.
Yeah. Well, I was going to save this, but since you brought it up, and Nirav, we'll get to your other question in a sec here. Do you think that's it? Do you think that, because I mean, let me disclose here. I love what you said about, what was it? F sub S?
F sub L?
F sub L, the final factor in the Drake equation.
Oh, okay.
Yeah, once you say I don't know to that, it kind of just blows the whole thing away. Because you know, I'm a little older myself. I was in high school in the 90s when we first started discovering exoplanets.
That's older? Oh, sorry.
But you know, before that, I was into science. Before that, I was reading Sagan, and so you know, I knew about the Drake equation and his efforts with SETI and everything. And it was like, oh my God, we're starting to get actual numbers in the Drake equation. And then as time goes on, we get more and more, we learn more and more. But at the same time, in reality, it's nice to know there's a lot of planets out there, but we still aren't really closer than we were, are we, to knowing if there's intelligent life out there?
To actually having a number? No, we're not any closer.
Which
so you
is
gotta
frustrating,
remember,
to use your term. I think you used the word
Yeah,
frustrating.
Exactly. You got to remember the Drake equation was not constructed as a way to get the answer. The Drake equation was constructed as a way to frame the question. And Frank Drake has made that point many times. It's unfair to say, well, we don't know anymore. Yeah, that's right. We don't know anymore. But there's so many different aspects to this question that if you don't do the typical scientific reductionism approach, you wind up thrashing around going, where do I start? And this gives some indications of what possible starting points might look like.
Yeah. I think it would be really interesting, and this is, I swear, Nirav, this is going to lead into your question. If we could identify life elsewhere in the solar system and be sure it's not, Rob, you used the term, I think it was you used the term panspermia before, and that it's not that life started there and came here, or that life started here and came there. Like if it worked on a different system than DNA or something, I think that would be really powerful if we could find that.
That would be awesome.
Yeah. Nirav asked, could you explain further why SETI is involved with tracking rings and moons?
A couple of reasons. One is they're awesome and knowledge is great. The other is those things indicate or put constraints on the theories or models of how planets and solar systems form. And until we know better how planets and solar systems form, we don't know what went into making them and trying to work out the history. Knowledge about these things is great. Another reason that moons are important from a SETI point of view is there's a fair amount of evidence that there are several moons in our solar system which may be biologically friendly. So the first one that comes to mind in many of these stories is Europa. One of the moons of Jupiter has more liquid water than all of the oceans on Earth. There's also the only other object in the solar system whose atmosphere is mostly nitrogen, where there are clouds and rain. Now the clouds and rain are made of methane and other components of natural gas, and the ground is made of frozen water, so it's mostly ice, but its atmosphere is methane. That's the moon Saturn of Titan. Another moon that has a fair amount of liquid water is the moon Enceladus, which is actually the source of, if you remember that picture I showed of Saturn backlit, there was a very faint ring around it. That ring is formed by the debris spewed out into space by geysers off the southern pole of Enceladus. Cryovolcanism, liquid or probably liquid water spewing out into space. Lots of places where we could have stuff, maybe even living stuff, if we figure out what living means.
Yeah, that's the other problem. This is, well, since you mentioned it, it's, what do you think about the idea of, I mentioned earlier about, well, if we could find life that doesn't run on DNA, how it might be kind of hard, because you're right, our definition of life is kind of squishy. Everything in the universe is a continuum. So it's all these definitions we kind of place on ourselves.
Except for quantum mechanics.
Right. So yeah, I mean, what do you think of the question is, how hard would it be able to even recognize extraterrestrial life? Let's say it's microscopic or, simple.
There are certainly ways in which it would be discernible that aren't immediately obvious. So, for example, life on Earth uses about 20 different amino acids in its structure of proteins. It uses 5 different nucleotides in the genetic code. There are lots of options. There are basically an infinite number of amino acids. There's a similarly huge number of nucleotides. We could have a system that uses proteins and DNA and RNA that at first glance looks identical to life on Earth, but in fact is different because it has a different choice of those nucleotides or those amino acids. So you can have things that use the same chemistry, but because of flukes of nature, accidents in the way things happen, turns out to be clearly and obviously different from life on Earth. So the problem isn't as bad as you might think.
Yeah. And we should mention too, I don't think you mentioned this during your talk, but it's not like SETI is the only method that we're using to keep our eyes and ears open. Do you know if the James Webb Space Telescope has gone up yet? I know that was delayed several times.
James Webb is scheduled to go up next month.
And I don't think this is a main.
No, November, next month.
And I know a part of that, it may not be a main thrust of its existence, is to look at atmospheric compositions of exoplanets, and that the idea that oxygen is not easy to get. A large percentage of oxygen in an atmosphere is not easy to get geologically. So if that is detected, that's a signal that something different is going on. Of course, that's a very Earth-biased look of life. Then we know there's Earth-like life. Maybe that's a suggestion, but it might be lots of different things. But that's one thing to think of.
So I think you're conflating SETI with searching for life.
Okay, to your point earlier about intelligence versus light
Yeah.
in general.
So there are lots and lots of things, and many of which are done at the SETI Institute, which have nothing to do with intelligence, like looking for moons and rings. Yeah, the James Webb Space Telescope, if we're very, very lucky, could be able to do spectroscopic analyses of the atmospheres of nearby, and it would have to be very nearby planets. And yeah, that'll be great. I look forward to that telescope launching and seeing what happens. Should be cool.
What is the main thrust for that telescope's existence? It's not that, is it?
Funding NASA? No, I didn't. Did I say that out loud? No. So if we're looking for the early information or information about the early universe, as the universe expands and we look further back, what was visible light becomes infrared. So we need to look in the infrared to find the first stars and the first galaxies. And because they're so far away, we need to gather more light. So that means we need a infrared sensitive telescope with a larger mirror. That's what James Webb is. It's an infrared telescope with a larger mirror.
Gotcha. So actually, Rob, I'll get to your question in a sec, but to go the other way, now, you said SETI is, I believe you might have said this, is expanding into optical frequencies also?
Yeah.
And what's the reason for that, in case I missed it?
Because that might be a way that we can find more things out. It's so it's another technique that we could use to send a signal. So why wouldn't they be doing it?
Right. I swear I'm going somewhere with this. I've got a two-pronged question here. And I think one of them is reasonable and the other part is specious. But
oh boy.
You could tell me, maybe they're both specious, you tell me. But I can imagine somebody making the specious argument. That's why I want to bring it up. So, of course, as you know, I agree with you that if we can confirm that we're the only intelligent life nearby us, that's a big deal. And that then makes it even more important to preserve this. The question is, and I hope this is the valid part of the question, can you ever really prove a negative? Can you prove that we're the only intelligence nearby, even if we're able to scan the entire visible whatever? That's part one. The second part that I can imagine a jerk making is analogous to the climate denier side, where they say, and I think we all agree this is ridiculous. They'll say, well, the climate scientists all agree that people are changing the climate so they can keep their jobs. That's dumb. That's not how science works. But I could see someone making a similar argument that, well, you started with radio and you said that was enough. Now you're moving to visible light. Next year, you didn't find anything radio, you moved to visible light. Next year, you're going to be in X-rays and you're going to keep going, trying to keep this thing going, trying to keep the money coming. What do you think?
Well, let's see. Let's start with the yes, that's specious in the case of the second one.
Right.
I don't remember anyone ever saying radio was enough. It was saying radio is what we can do with current technology, so let's use it. As high-speed optoelectronics came into existence, it was realized that that could be used, so we're using it. I kind of doubt X-ray is going to be in there anywhere, but if we figure out some way that extraterrestrials could be signaling us with X-rays, that'll be cool. My PhD thesis was in X-ray astronomy, so I'm interested in X-rays coming from stuff out there, but yeah, not the first thing that comes to mind. But that's good. If we learn something new, that'll be fine. As an effort to keep the money coming, sure, except for the fact that SETI was a victim of the Golden Fleece Award. And as a result, there is a extreme reluctance for SETI research itself, not the SETI Institute, but for SETI research itself to be funded by the federal government.
Oh.
Can you explain that Fleece Award reference?
So I'm trying to remember, was it Senator Proxmire was a big opponent of government waste, and he came up with something called the Golden Fleece Award, where these nasty scientists were trying to fleece the American public by supporting research that was just stupid, and wherein he demonstrated a profound lack of knowledge about how research works and what is actually interesting science. But it got lots of press and was a big deal. So there's a lot of reluctance that's based on that. So what was the first part again?
The other part is how do you it would be great to know, well, it would be sad, but like you said, truth is important.
Right.
Truth is
Okay,
beautiful.
so
It would be great to know if we are the only existing.
right, but how could we prove it?
How can you know
Yeah,
that?
and we can't. We can't prove it. We can look carefully. And as I pointed out to Benny earlier, there's an awful lot of signals coming from us that isn't deliberate attempts at signaling. And if we don't see anything after we've looked hard enough to have found what we're putting out accidentally, then we can be more confident, but we can't prove it. Proof is something that really belongs only in mathematics,
Right.
and I don't know, vodka. But we don't prove things in science. We demonstrate that something is a good model or not a good model.
And this is more of something for the astrobiologists to debate. But then, people will also talk of, well, you could have an intelligent civilization that doesn't use technology. What if they're super smart, thummy dolphins? I don't know. But they wouldn't want to talk to us anyway. So in that case.
Yeah, maybe.
Yeah.
I don't know. I don't know how many of you have read Andy Weir's new book, Project Hail Mary, but that talks about a very non-human extraterrestrial that develops technology. I don't know if dolphins just can't because of their biology, or aren't smart enough to. I don't know.
Or there's no reason to.
Or there's no, well, there's certainly a reason to. They, could get more food with less effort and be able to spend more time, singing to other dolphins, which sounds like fun. I'm sure that if dolphins had a way to expend less effort, get more food, and be more protected from predators, they'd do it.
I know this is a question from Rob, and I know I saw this addressed, but I don't remember what the answer was or how the answer went. There was that thing about Venus recently about there was a detection of a gas that's usually associated with life. Do you remember that?
Phosphine.
Yeah. But
Yeah.
didn't figure out where that was actually coming from?
No,
Oh, I thought
they haven't figured out where it's actually coming from. There has been some question raised as to whether or not the data analysis was done correctly, and whether or not they adequately protected against systematic errors.
Gotcha.
So it may in fact be that there is nothing there, that the signal is wrong. But we'll know more in not too long, because there are a couple of more spacecraft going to Venus to look for this.
Interesting. Very interesting.
I saw on a tangentially related thing, I saw on one of the many science hype sites that are on Facebook, a assertion that penguins must be aliens because they found phosphine in penguin poop. And how in the world could a chemical from Venus make it to Earth unless penguins are aliens?
That's fantastic.
I believe there are some scientific leaps there that
Actually, you know what? I Googled phosphine Venus as we were talking about it. And the first things that came up were about penguins. I didn't look at them. I was like, all right, this is something.
yeah, it's I'm not going to say in a recorded Zoom
Amazing.
how
Amazing.
completely ridiculous that is.
It's backwards.
It's nutty. Well, let's just say phosphine was first made on Earth in the 1700s, and we had a name for it before it was found on Venus. So it's clearly not just a Venusian chemical.
Okay, we got another question here from Nirev. I saw something in the news about wildfires potentially impacting SETI telescopes. No recent articles about it, seemingly, though.
So the SETI Institute Allen Telescope Array, which was the last picture that I had in my presentation, is in a radio quiet zone between Mount Lassen and Mount Shasta in Northern California. And the fires around Mount Lassen were therefore not all that far away. And that's scary.
But it didn't impact any,
Not that I know of.
it didn't hurt visibility or anything, or?
Oh, no, it's certainly not going to hurt visibility.
Okay.
They see through that sort of stuff easily.
Yeah, smog. All right, so if anybody else has a question, write question in all caps in the chat and let us know. But here's another one I got for you, Leonard. What do you make? Well, I'll tell you, let me say this first. There was an article in Skeptic years ago that really opened my eyes by a guy named George Michael, not that George Michael. But it addressed the question of, do we have to be afraid of alien intelligences? And Stephen Hawking has said we should be careful about contacting alien intelligences because, you know, the history on Earth of meeting, you know, other peoples isn't very good for the people who are less strong. Is that a concern you share? And when you answer that, I'll bring up the article I was talking about.
No, it isn't. It's not a concern I share because I think space is big and it's hard to move from place to place. And we could be in a galaxy teeming with technologically advanced civilizations, and they're not coming anywhere near us because space is big. Yeah, so not scared.
Yeah, and that was definitely a part of the article I'm thinking of too. But it was also that, like, space is so big and it's so very hard to travel across it that if you can do that, you've probably figured out other ways to get resources. Like if you're coming here for our minerals, you know, why couldn't you have gotten those from asteroids? If you're coming here for food, you've probably figured out a way to easily make food by now. You've probably built a Dyson sphere around your star, if that's a possible thing, to get all your energy that way. You don't have to come light years across the universe. That's wasteful. That's inefficient.
But maybe we're just really tasty, and they're here to, as the story was titled, to serve mankind.
Yes. Yeah, it's just not logical. Yeah. Anyway.
Yeah, not worried.
Pamela had a question that I missed. Thank you, Nira, for pointing it out. If SETI finds evidence for the current existence of intelligent extraterrestrial life and its location, is there a plan to attempt to communicate? What would the next step be?
I'm not sure that it's a well-documented plan. There are reasonable plans to answer the question of how do you make sure it's real? There are lots of facilities and organizations that are interested that will try to back it up. But it's awfully hard to, so the first question is, we find something. Then we have to make sure that the something is real and that it's not, to use a recent example, a microwave oven in a nearby building. So there was a radio astronomical phenomenon that turned out to be leakage radiation from the microwave oven. People were pushing the button to open the door and shutting the microwave off that way. And that little tiny bleep of microwave radiation was getting into the radio telescope. So first we had to make sure that the signal is real and not caused by a microwave oven. Then we have to determine whether or not the signal has a message in it. And that's not going to be easy. And then the really hard part is figuring out what that message is. And the only way, and there's no plan to do that, but there are a lot of people whose sort of full-time job, I think he's still at the SETI Institute. There's a guy who's director of alien communication, basically. And he's really smart, and he spends his time figuring out how to decode signals and how to encode signals. So when we get more information about the signal, when we get it, and we figure out that it's real, and we figure out what it's saying, or that it's saying something, then we'll go further. But I think the best answer is you get really smart people, and they think really hard about it.
And to kind of combine 2 points about making sure that the signal is what you think it is, and the other benefits of SETI, the big wow, was that involved with, well, explain what that was, and was that involved with the discovery of something new to the universe that we weren't aware of?
So that one wasn't.
Okay.
So there's something called the wow signal, where there was a radio telescope that was pointed at some star. I don't remember which one, and there was a signal. And the guy who first looked at the paper output circled it and wrote "wow" next to it because it was unusual. So it's now brilliantly known as the wow signal. We don't know what it was. It hasn't repeated, and nope, no information, unfortunately. There are a couple of other signals that were seen that were mysterious that turned out to be scientifically incredibly useful. There's a fairly famous example of a new radio telescope being built in England. The graduate student working on it saw a signal that she described as looking like grass on the data output. And she went to her advisor and said, "Hey, what's this?" He said, "I don't know. I don't care. Not interesting. Come back when you have something interesting." And she kept working on it and changed the way the data analysis was done, and figured out that this was a high frequency radio signal that was pulsing on regular intervals. And she went back to her advisor and said, "Hey, what is this?" And he said, "I don't know. I don't care. Go back and do what you're supposed to do." And she cleaned it up some more and found that they were incredibly regular signals that were quite powerful, coming from a particularly interesting direction in space. Went to her advisor, and he got the Nobel Prize in physics.
No.
Those turned out to be pulsars.
Right. That's what I was getting at. Yeah. Okay.
Yeah, this was not a pulsar.
Yeah. Okay. That was a much better story, and while at the same time being soul crushing. The rest of panelists' question that I think you probably kind of got to was if you did identify an alien signal, would SETI continue searching for more or just focus on what was found?
Yes.
Good answer.
So my guess is if SETI did find a signal, it would be easy to do both because SETI would have a lot more money to build more telescopes and get more telescope time.
Aha.
And knowing the people at the SETI Institute, as I do, I don't think they'd be willing or even consider. I don't think the thought would enter their mind to give up on looking for others
Yeah.
when we know we found one.
If anything, that's justification to push harder, right?
Yeah.
Another one from Nerev, and we kind of talked about this. If we find non-intelligent life elsewhere in our own solar system, how do you think that would impact SETI? Or would it?
So that's a really interesting question. I keep hearing if we find proof that there's life elsewhere, it'll change everything. If we find evidence for aliens, that will change everything. Nonsense. Back in the 1930s and 20s, when we had the Mars silliness, the Orson Welles radio show, it was commonly believed that there was intelligence on Mars. This was a run-of-the-mill standard assumption by everybody. Didn't change things. People still, went to work and did the stuff they do. Yeah, I don't know. If we find it, it will have some effects. I'm a physicist, not a sociologist. I'm not even going to attempt to figure out how society is going to act. I have enough difficulty figuring out how I'm going to react to new information, to say nothing about my wife, who is also on this call somewhere.
All right. Oh, we got another question. Okay, so let me ask you this actually. So does SETI? We mentioned the question of funding before. Does SETI get nothing from the federal government at this point?
So SETI itself, the search for extraterrestrial intelligence, I'm pretty sure gets nothing. The SETI Institute, through its astrobiology work and by getting contracts from NASA, does get money from the federal government.
Nerev asked, I believe yes, does SETI get funding from any foreign governments? Or maybe the better question, do you know if there are similar programs outside the US?
I don't know off the top of my head if SETI gets funding from other governments. I suspect that they do, because there are joint programs between the US and other countries. And yes, there are other institutions and organizations around that world that do similar things.
Do you know if there's coordination there? So like not everyone's looking at the same patch of sky or?
Oh yeah.
Okay.
It's actually not a big issue. There's the sky's
Yeah.
big. But yeah.
Just in case.
Yeah.
Well, actually, now I think about it, speaking of the sky being big and there being a lot to search, are there still efforts? Like, I know there was a thing called SETI at home at one point, right? Is there a way that you can all contribute to this somehow?
So SETI at home use data from the Arecibo telescope.
Oh dear.
And even before the Arecibo telescope did, as Elon Musk would call it, a rapid unscheduled disassembly, that program was ended. So no, not for SETI at home. But yes, of course, you can contribute to the SETI Institute and any other organization that is doing this sort of work. As a member of the Council of Advisors, I strongly suggest that you consider your tax-deductible donations. This has not been a commercial.
But it reminds me to say the New York City Skeptics is also a nonprofit organization. Check the link I just put in the chat. If you like these talks and others, feel free to make your tax-deductible donations. Thank you for reminding me, Leonard.
You're most welcome.
In addition to stars in our galaxy, the SETI will also look at other galaxies. I think that in our galaxy is probably enough to start with, right?
Yeah, I think actually one of the early calibration runs for the Allen Telescope Array was a survey of Andromeda, the nearest large galaxy to our own. So yeah, they look, they didn't expect to find anything. But yeah, looking is good.
It's good. I also put a link to our YouTube channel in the chat. This will go up on YouTube at some point. Let's see. Again, like I said, the AIPT Sci-Fi Fest talks are going up if you missed those. If anybody else, Leonard, if you're okay with this, I'll say anybody else wants to get in on the chat, unmute yourself if you feel like it, or if you can't, tell me and I'll do it for you.
Yeah, let's see if we can make this cacophonous.
Can I, I'd actually posed the question, if a telescope is being used for SETI purposes, is that exclusive, or they can sort of listen while the telescope is being used for something else?
Oh, they absolutely can listen while the telescope is used for something else. So most of the data that was analyzed by the SETI at Home program was sort of sideband stuff that was being gathered while Arecibo was doing other stuff. So absolutely. There's a wonderfully deep technological and mathematical rabbit hole that you can go down if you look at the math and science of radio interferometry. So one of the reasons that the Allen Telescope Array and basically all new radio telescopes are being built the way they do is it allows you to simultaneously look at multiple high resolution parts of a low resolution wide field at the same time. It works. We'll call it mathematical.
I actually meant to say this earlier, Leonard, but I kind of had the opposite experience of Craig, where when, you know, I met you at Nexus, we talked at Nexus, we were friendly at Nexus and maybe at SciCon too, I can't remember at this point. But this was before I knew your reputation, and I thought you were just a fun guy who hung out at skeptics conferences. So,
well, I hope that's enough.
That's true.
It was. And then everyone was like, "Oh my God, that's Leonard," and I'm like, "Yeah, he's pretty cool, right?"
Yeah, every once in a while, someone will recognize my last name.
Right.
And go, are you that Leonard Tramiel? And I go, I don't know. Who do you think I am? Yeah, it's a little weird.
Craig, did you want to say something? Go ahead. I see your hand.
I put a question. I don't know if it's showing up.
Oh, I didn't see it. Go ahead.
Isn't it more about, you know, what seems more important is our own thirst for knowledge on the question. And even if the answer, I always have loved the answer, the answer I don't know, because it always leads to more questioning. So sometimes I don't know is just as enjoyable as finding out, but it's part of our, do you feel that ultimately it's our search, humanity's search? And do you think other forms of intelligent life will come to the conclusion, we don't know, but we need to know, and we'll also search? I mean, is searching unique, you think, to intelligent life for each other?
Okay, so let's try and go through those in reverse order. Do I think that searching is unique to intelligent life? I think by definition. I don't think you can have a thirst to search without intelligence. That being said, I don't know what intelligence is, so I'm to use a phrase I learned from my kids, that was mostly rectally inspired. But I think you know what I'm talking about. I think that that was one of the things I was trying to say in my talk when I said that SETI brings out, from a scientific point of view, the most positive things about being human. That's what I meant. We're trying to find knowledge. We're trying to learn more. And that's what it means to be human. That's one of, as far as I'm concerned, one of the main benefits of being human. And it goes back to that Robert Wilson quote, it doesn't make the country safer, it makes it worth saving, or doesn't add to its protection, it makes it worth protecting. It's a deeply human thing, and it's one of our better impulses.
Can we go back now? Obviously, well, maybe this isn't obvious, but it would be much easier for SETI to detect an intentional message, correct?
Yeah.
You brought up the unintentional, frequencies that were kind of leeching off all the time. And I believe you mentioned it, but I don't quite remember what you said, but is that something like, our spurious TV frequencies that leech off into space? Now, that's not something we could detect around an exoplanet, is it? Because they spread out too much, right?
We've got some pretty darn sensitive radio telescopes.
Huh.
So it's not unreasonable. But the unintentional signals that are most powerful from the Earth are military radar.
Oh.
So there's no information in those. It's just, beep.
Yeah.
But it's going to look darn artificial.
Right, because I would assume it's periodic, or at least
It's periodic. It's very monochromatic.
right.
So single frequency.
Right.
Yeah,
Okay.
it's going to look different.
But don't these signals on this question, don't they dissipate quadratic? So
No, not well. They go off as the inverse square.
Yeah.
Yeah, it's an inverse square. It gets smaller, but we're good at finding stuff.
And hopefully we'll get better even.
Yeah. So one of the things that came up in a discussion about skepticism the other day, people will say, and I'll be as generic as possible, substance X was discovered in product Y. And most people go, oh my God, substance X is poisonous and I eat product Y all the time. And my reaction when I see that is, damn, we're good at finding substance X. Yeah, we're good at finding weak signals. So I'm not all that concerned about the inverse square law. On the other hand, light drops off at the same rate as radio frequencies. And we have, I've got, on the wall behind me, a picture of a galaxy that's 400 million light years away. So I think we can deal with the inverse square law.
How do you think it would go? That's interesting what you said about the military radar. I never thought about that. What do you think would happen? Or imagine a scenario in which somebody proposed a directed signal, kind of like the type we've been looking for, a beacon to alien civilizations to tell us that we're here. Do you think there'd be a lot of that panic and people saying, no, you can't do that? Or do you think it would be more?
Well, it's been done.
Yeah. Oh, really?
Yeah. So the now destroyed Arecibo telescope, one of the first things it did, so Arecibo was not only a receiver, it was also a transmitter. And that was done for radar purposes, to be able to radar map passing asteroids, We know the distance to the planets like Venus and Mercury and their rotation speeds to high accuracy because of Arecibo. But one of the first things that was done with the transmitter was they sent a signal in the direction of one of the larger globular clusters orbiting the Milky Way, something called the Hercules Globular Cluster, or M13, which is tens of thousands of light years away. So we're not expecting a response anytime soon.
But do you know what the duration of that signal was? How long was it? How long did it?
I don't remember how long it took to transmit and how many times they transmitted it. Yeah,
Because
but
that kind of touches on another problem, is that if technological civilizations don't last that long, then there might have been some out there, but we could have just missed them, or maybe we're the first.
Yeah. So when people talk about, well, how exhaustively have we searched? And should we be disappointed at this point? We've barely looked. If we look at the multidimensional array of space that, frequencies and distances and durations and all that stuff, we've barely investigated at all. And as Jill Tarter has put it, if you walked to the seashore and stuck in a shot glass, pulled it out and saw no fish, would that mean that the ocean was sterile? No. So there's a lot more looking to do, and shouldn't be disappointed.
Anybody else? You want to unmute, get in on this? Craig, go ahead. You don't have to raise your hand, sir. Craig?
Change this mind.
No, maybe. All right. Does anybody want to ask?
I just want to ask one sort of a comment question.
I love those.
I mean, the what?
I love comment questions.
Comment question. So
I figured out how to-
when I hear the word SETI, it sort of triggers in me something that says, oh, they're not going to find, why are they wasting time if there's no intelligence? Why not just settle, right? Search for extraterrestrial life, which is great. But on the other hand, there's a lot of people that don't really care, that are really inspired and are really motivated by finding other intelligence.
Yep.
So that was sort of my question, comment. What are your thoughts on those two reactions?
It's absolutely normal. In fact, one of the things that we talk about in discussions around at the SETI Institute is the giggle factor.
All right.
When people hear SETI, they giggle. It's a funny idea. Are you really seriously suggesting that we donate money to find little green men? And yeah, that's a normal reaction. On the other hand, as you correctly pointed out, there are people that are tremendously inspired by the possibility of finding intelligence. They find intelligence to be useful, or at least most of them find the intelligence of the very few people that are intelligent enough to actually push society forward. They find that useful. But yeah, so you've got the phrase, it takes all kinds. I'm not sure that's true. There are some kinds we could probably do without, but all kinds are available should we find that they're needed.
You know, that inspiration idea, I didn't make the connection before, but that's exactly why I came around on the thought of sending people to Mars, or at least trying to do so, because, Leonard, you can correct me if you think any of this is wrong, but it just seems it's so wildly inefficient to try to send people to Mars. Like, robots can do so much more. We already have a sample return mission going on.
Well, we have a sample mission, and we're thinking about doing the return part.
Gotcha.
There's no plan yet for the return, but
Oh,
there's
really?
a plan. There's a plan to make a plan.
Okay, good enough.
We have the
which is-
sample ready, right?
We have a sample ready.
Right.
But at the
And-
same time, if we could send people to Mars, that would be, I think, a very inspirational thing.
Well, there are two things. If we could send a person to Mars, if we could send people to Mars, that would be wonderful. There would be inspirational and all that stuff. Plus, people are good at stuff. The robots that we have on Mars right now, the chemical analyses that can be done by the robots on Mars, is pretty minimal. The big issue for me, thinking about it, is how do you get someone to Mars without them dying? The radiation problem is a big one. And it's not being considered all that seriously by
Really?
some of the proponents. NASA is paying a lot of attention.
Okay,
But not everybody is.
that's too bad. Because other than the, food and everything, that seems to be the biggest problem. Like,
Yeah. So what's your question, Craig?
So I'm switching to science fiction literature and intelligent life. The science fiction literature I read as a kid seemed like Isaac Asimov was the only one who never had aliens in his literature, except for a shoot-off series that other people wrote. Everyone else had intelligent life. Do you feel Isaac Asimov felt that we were alone?
I don't know. Maybe. I never had the good fortune to meet him. I don't remember. I read a lot of his stuff. I don't remember anything where he explicitly mentioned it. I get the feeling that he was just a good scientist as well as a wonderful science fiction writer. And he found enough amazing, fascinating, captivating stuff in what is known and simple extrapolations from that to make great stories that you didn't need to go further.
That's the most beautiful explanation I've ever had for the question of why Asimov doesn't have aliens as his main subject. All right.
Yeah, I don't know.
Yeah, I don't know.
A funny story. So I was a graduate student in physics at Columbia University, and I used to run the observatory open house for the astronomy department. And one afternoon, the phone rings in my graduate student office, and it's the secretary for the astronomy department saying, "Could you please come up and open up the dome? We need to do a photo shoot. Some science fiction author, I don't know, Isaac Asimov or somebody, is coming by." And that was the closest I ever came to exceeding the speed of light. I was upstairs as near as I could tell instantaneously, but it was not Asimov. But I must say I was not terribly disappointed. It was Arthur C. Clarke. And the photographers had screwed up and left their lens bag back in their studio downtown. So I had the wonderful problem of keeping Dr. Clarke entertained for an hour or so while they went down to get their images, get their lenses for the picture. Yeah, that was a fun afternoon. But yeah, never got to meet Asimov.
do you remember about when that was?
That would have been late 70s, early 80s.
Yeah, that's kind of what I
Yeah.
figured. Yeah. Because
Yeah.
it's interesting because I would expect, I'm not huge into science fiction, but I understand that Asimov and Clarke are both very highly regarded. And
yeah.
Asimov, of course, was involved with the founding of SciCop, correct?
Yeah.
And Clark, one of my favorite TV shows as a kid in the 80s was his Mysterious World, where he looked at weird stuff.
Yeah.
I feel like he was a little more skeptical than that program would give off, but at the same time, you see a little bit of a divergent path there.
Well, he was in fact a lot more skeptical.
Yeah.
So Clark was actually personal friends with the founder of PsyCop, and who I got to meet and get to know pretty well for the first time on a CFI cruise to the Amazon. We did a 8-day river cruise on the Amazon. And one of the things that I found out then was that Arthur C. Clarke was scheduled to be on that cruise.
Wow.
He unfortunately died before. He had post-polio syndrome, and that ended his life rather suddenly. But yeah, that would have been fun.
Leonard, that was fantastic. Thank you so much.
Glad everybody enjoyed it. And we'll, if you really do need to scrape the bottom of the barrel sometime, let me know, and maybe I'll join in again.
Thank you, Leonard.
Leonard.
Thank
Thanks,
you.
everybody. Bye-bye.
Bye.
Bye.